Oh, wake up, samurai. Okay, so here's our first converging lens problem. What is the position and size of the image of a 7.6 centimeter high flower placed 1 meter from a 50 millimeter, millimeters, what? Focal length camera lens. And maybe this flower is like a rose, like a stunning, brilliant rose that shines through the darkness and breaks up the world. And maybe there's a field of them approaching the tower. Roland of Gilead. Anyways, that was weird. Okay, so let's take a look at this. If we have a 50 mil focal length, I got all sorts of different units here. Centimeters, meters, millimeters. Okay, let's just put these all into something useful. Let's just make them all centimeters. Okay, so this will be 100 centis. This is going to be 5 centimeters. There we go. So if our focal point is here at like 5 centimeters, we are well outside of that. Okay, we're well outside of this. So we know we should be creating a real image here. This is something like case 1 because the center of curvature will be sitting at 10 centimeters. So if we just kind of do this with a quick ray diagram, let's say this is the focal point. What's going to happen is we're going to get a ray coming through. It's going to strike the mirror, do its little like double angle change thing, and then come down through the focal point. And our second ray, we are going to just send perfectly through the center of the lens. I hope I didn't say mirror before I meant lens. Pass it right through the center, and that will form our image right here. So that's our image. So that's what we should see. We should see an inverted image, which means it's real. In theory, this should be a little bit smaller, and we'll see how this works out here. So let's see what we got. If we'd like to determine the image distance, di, let's use our lens mirror equation to do that. We know 1 over f equals 1 over di plus 1 over do. And in this case, since we're looking for di, we can rewrite this so that it says 1 over f minus 1 over do equals 1 over di. Plugging in some numbers here, we know our focal length is 1 over 5 centimeters minus our object distance is 1 over 100 centimeters. This is going to give us 1 over di. I'm very careful when I add these together, or subtract them rather, because I want to take the fractions first. This isn't like 5 minus 100 and then divide by 1. You can't do that. So 1 over 5 is 0.2. That's 1/5. And then minus 1 over 100, 0.01. So we're going to get 0.19. And that equals 1 over di. And then we take the reciprocal of each side. So flip move, and 1 over 0.19 gives us that the distance of the image should equal 5.26 centimeters. Okay, so that's what we should get for the image distance here. So it sits just outside the focal point there. If we want to figure out the magnification, we know magnification equals the opposite, or the negative, of di over do. So the negative represents that we are inverting here. We're flipping, making that the real image. And then we're going to have 5.26 divided by 100, very small. That's only about like 5%. Our magnification here, what is 5.26 divided by 100? Well, I could do that in my head. That's so silly. It's going to be much smaller. It's going to be 0.0526 on the negative, meaning that it's inverted. Okay, so that's our magnification, that's our image distance, and we saw that in our ray diagram right up here. So nothing too crazy. Probably the hardest part about this problem was just recognizing that things are in centimeters, things are in meters, things are in millimeters, converting that. If I actually wanted to find the true size of this image, I know it's magnification. So if I simply multiply it by the object of the flower, the height of the object itself, which is 7.6 centimeters, 0.0526 times 7.6 centimeters will give me an answer of centimeters, so times 7.6, and that'll actually say that this flower is going to be about 0.4 centimeters tall. Okay, that's the true height of the image. Negative just meaning that it's inverted. Okay, and I kind of ignored the negative there because of the convention thing. So that's it. That's all we got going on in this problem. It's nothing too crazy. I hope you enjoyed it. We'll be looking at some more problems moving forward. But for now, this is finished. Adios, and take it easy.